Thank you all for dialing in here to share with me my work. It's been focused on irregular shelterwood silviculture. Shouldn't be any accident of how we got to this place. Late in 2017, this fellow on the screen, Bill Leahy, called me and wanted to know if I wanted to serve on a independent review of forest practices in Nova Scotia, and he explained why. And I said, "Well, why not?" Long story short, we met during the early 2018. By August, the report was released. Bill wrote this mostly himself. This was a remarkable achievement, actually. 163 conclusions, 45 recommendations, and my triad concept that Mac Hunter and I worked on beginning 30 years ago was kind of a key framework to all of this. The focus of this seminar here is going to be on the management of the triad natural forest matrix, that core forest that sort of buffers the ecological reserves in the high production leg. Okay. Why was this review there? I probably don't need to tell you this mostly, but until 2017, there was just a lot of clear cutting going on in Nova Scotia. Many people's view way too much, especially relative to the natural disturbance dynamics that the Acadian forests are driven by. And so roughly 80% is the data we were presented with in the Leahy Commission. Contrast that to Maine, where I work, 6% of the harvest here are clear cuts, and of a total of 400,000 acres annually. So just a tremendous difference across the border. So just to get right to the heart of the matter here, if you're faced with a situation where you want to sort of green up or make forestry more ecologically based through changing your practices, how do you do that? Well, we have Jerry Franklin. Let's just contrast Jerry's approach with mine. Jerry, of course, is a really prominent forest ecologist from the Pacific Northwest. Jerry's been, his whole thing is variable retention harvesting. That more retention, in any kind of big harvest block is the solution to everything. I've long felt that variable retention, while it may be an improvement over what was going on in the Pacific Northwest, is not a silvicultural system. It's just a logging pattern. It's just taking something and what was formerly a clear cut and leaving some trees standing out there. He, of course, would argue it's more than that, and it probably is. But the fundamental problem for me has always been that this variable retention approach doesn't include or discuss regeneration. Not that it can't in other formats, but it really doesn't explicitly. So when my colleagues and I were talking about this, it's like, well, what are we going to do, right? And, we need more retention, right? We need to make the clear cut smaller or whatever and leave more standing. And I basically just try to persuade them that's not going to work. Clear cutting with more reserves is not the solution here. The solution is, when you're faced with this problem, is you need to make a more fundamental change within the silvicultural system such that it's consistent with the natural disturbance regime, especially the regeneration process, not ignoring it. That's a crucial feature of any silvicultural system, just as natural dynamics regeneration is critically important to those. Irregular shelterwood, which we'll explain in detail forward here, is to me is a key solution to this problem for reasons I hope will become evident if you're not already convinced. Now, this, of course, will probably involve more retention as we know it, but it's just a bigger change than that. That just leaving more trees standing when you clear cut is not the solution. Just to review what I wrote for the Leahy report, just to give it more context so you can hear about me. I wrote that this was about the forest management guide. As I got into what was going on in Nova Scotia, obviously the reference material in the forest management guide was critical because this is what all the Crown licensees used to guide their harvest patterns. And I just wrote, by the time I had it, I brought it home. I had some of my friends and colleagues review it, and it was obvious what the problem was right from the get-go. It wasn't that the clear cutting per se, it was that the silvicultural systems were almost preordained to be very even age, single cohort forest management for virtually all the forest groups that were in the guide. And then when you work through the decision trees, I mean, I said here that they use questionable criteria for stand maturity, appear to be too eager to establish and release regeneration at the expense of retaining growing stock for longer periods, and don't mandate any kind of structural retention, among other things. It's a longer answer. So that was a critique. You can, if you read that chapter 14 of the Leahy report, you can read the long version of this. I went on to say that if, there's a solution, right? You just can't point out a problem. You got to figure out what to do about it. If forest management in Nova Scotia were truly ecosystem based, using natural disturbance regimes and other ecological science to guide silviculture, then one would expect the management guide to prescribe multi-age silviculture on the majority of the landscape, okay? The natural landscape, at least, the matrix forest. And I think I realized that this was a brand new thing to Nova Scotians. Some people hadn't even heard of irregular shelterwood. When you said multi-aged forestry, they immediately thought of things like single tree selection, the extreme polar end of multi-age forestry. But multi-age silviculture is far from that. In fact, that's just a really small part of it. Is not limited to that. But it includes a broad array of 2 or 3 or more aged silvicultural systems. So anything other than a single cohort system can be, under modern silviculture thinking, is considered multi-aged, including the 2-aged. We'll talk about, if you see ISW, that just means that's my abbreviation for irregular shelterwood. And it's just a much more flexible way to emulate the natural disturbance patterns that are out there, and among other things, and still be efficient about it. As I said, this is not new. I wrote about this 30 years ago in a book chapter. At the lower right here, you can see, this was my attempt to just diagram some simple pathways for regenerating mature spruce fir stands. And one of them was do a shelterwood establishment cut, and then an incomplete overstory removal, leaving reserve trees. And now you have an irregular 2-age stand. This is part of silviculture basically forever in North America, but for somehow these kinds of systems never seem to have made it into mainstream thinking in at least Nova Scotia, New Brunswick. However, our friends in Quebec, Patricia Raymond and her colleagues there, published this, what I think has become a seminal work on this irregular shelterwood system, and we'll refer back to the details of this later. I'm just showing it here to give her credit, and she really showed that it's not just about multi-age forestry, a different way to do it, but it is how it is very well suited for natural forests that are affected by partial disturbances, which of course are most of the Acadian region. This, of course, will all eventually find a place in the new forest management guide. We're now calling the Silviculture Guide for the Ecological Matrix, or the SGEM. And the preamble to this, and even the one that was circulated back in March, basically the whole fundamental premise of this is now very strongly ecological. It's about managing the triad ecological matrix of the triad zone, where, and the right quote directly from Leahy, conservation and production are both applicable and combined. So that's the context here. This is, I guess I say, under active development as we speak. Before we get to the details of irregular shelterwood, let me talk a little bit about just plain shelterwood, just so we have our semantics. Shelterwood, of course, is one of the regeneration methods in silviculture that relies on advanced regeneration that that develops in partial shade before the overstories remove. And conventionally, this is thought of as it's more or less an even age system, sometimes a 2-age system, but we relax that for irregular shelterwood, where the cuttings are all near the end of an even age rotation. You can have preparatory cuttings. You rarely hear people talk about those. The key step really is the establishment, or used to be called the seed cutting, where you do a partial harvest, leave over wood, and the goal is to establish your advanced growth. And then after that advanced growth is established, then you do removal cuttings. These is to release the advanced regeneration. And there can be more than one of these if you want to leave structure, right? They can be partial, complete, or incomplete. For shelterwood also, it's a great system, right? It has the flexible, because it has the spatial variancy. The common one, of course, is uniform shelterwood, where there's no reason, where the stand is uniform, then why do anything different? where the regeneration's recruited uniformly, leaving a sort of a uniformly stocked overwood in the establishment cut. If the stand is patchy, you can do group shelterwood, right, where you treat different patches of the stand with different stages of the shelterwood sequence at the same time. So some would be, maybe you have advanced growth came in naturally, you do overstory removal there. Other places where there isn't any, you do establishment, etc. And then you can, another spatial variant is a set of groups you can do long, and you can do narrow strips. Basically, they can't be more than about a half a tree in height, or you're losing the shade that you need for shelterwood. They're essentially linear groups. You can, 20 years ago or so, at least in the United States, we started leaving reserve trees. So you would have any even age system can do this. So you can have shelterwood with reserves. These are trees that are left for of the older cohort left after the final regeneration harvest, usually in an even age system. For reasons not related to regeneration, these are not seed trees. These are not overwood trees. They're trees left for a variety of other purposes, which you'll show here in a minute. So that is a common way to take an even age stand, regenerate it with some retention, and create a 2H structure, the simplest variant of irregular shelterwood. These reserves may or may not be harvested in the future. There's nothing that preordains them to be kept forever, but you certainly can do that if that's what you want. As I mentioned, they can all have these. So we would say just uniform shelterwood with reserves, or irregular with reserves, whatever. When I taught this for 30 years, and the timing is also different. The timing of the regeneration period, traditional shelterwood is pretty short. You keep the regen there for 5 years, and off comes the overstory, right? You want to daylight it. If you have a species that are intermediate in shade tolerance, or even intolerant, like black cherry, that do benefit from the initial shade, but then will die if you don't release them, this is what you do. The classic, simple, bang, bang, sort of, establishment cut, and then quickly conventional removal within 5 years or sooner. Extended shelterwood is more what we would tend to use for our more shade-tolerant species that need a longer period to become established, and especially outcompete intolerant competitors like paper birch or raspberry weeds that would come in if you opened the overwood up too soon. Spruce fir is a classic example of this. So you would divide, this is where the final removal cutting would be delayed until the advanced growth is up to small sapling size, say just barely above breast height, or up to 3 or 4 meters, something like that. Extended shelterwood. And then finally, we have irregular. Irregular, classically in the older literature, was defined as there's really no defined regeneration period. It's sort of drawn out. And you would keep some of the mid-story trees as kind of an older, members of the older cohort, kind of held over into the next rotation. So it's kind of in a never land between classic old-fashioned even age systems and something like a single tree selection. That's a general definition of it. We'll get a little more specific here. What defines irregular here? What are we talking about versus the other systems? Is, as I just said, the regeneration period is drawn out for a longer period, and in such a way that when the overstory, the re-entries are made to remove some, not all, of the overstory, the height structure of the residual trees is very irregular, because some of them are older than others, right? Or have been growing more rapidly, right? So you don't have this distinct 2-story canopy like you would in a classic even-aged or 2-age shelterwood. Now, eventually, in an irregular system, if under a timber sort of economy, all the large trees would be harvested. If you were designated permanent legacies, of course, you would leave those, but then the stand would go through several decades of stem exclusion. So this is not a balanced system like classic selection systems are, where you cut very regularly every 5, 10, 15 years, essentially forever, and the stand would have 20 cohorts. It's pulsed, and it's designed to replicate these, what you might call mixed severity, or sporadic gap disturbances, partial disturbances that don't kill the overstory, but do regenerate substantial portions of the stand. And you would typically, under management, irregular shelterwood would always have 2 or 3, perhaps more cohorts, probably not 20 or even 10, right? Like you would have in a classic single tree selection, right? And this would depend on the variants, which we'll get to. Why would you use this instead of simpler variants? I think it's the main thing to me is that it's better at conserving growing stock. We have 20 species in our Acadian forest. They all grow at different rates. And if we grow them all like they're loblolly pine or paper birch or aspen, or something that grows fast out of the gate and then dies young, we're not going to reach many of the later blooming, the later successional species will never reach maturity. Irregular shelterwood kind of sorts over these trees and allows you to retain those, right? If you can deal with that irregularity about the stand, and there's just no problem with that, right? We've always done that here in the United States. It doesn't create problems. It seems to be a newer thing in Nova Scotia. It does rely on these trees to be able to respond, which of course they do. And there's a concept that's emerged here that we call two rotation species, or sometimes I even call it tall regeneration. Trees that are 10 meters tall, they can be 50 or more years old, but they're far from mature, and you can just think of them as just they're going to be carried through the whole next stand. Let's call those tall regeneration. They're not seedlings, but that's okay. And it's a great way to restore complexity in forests that have been simplified by past more even age management. These two rotation species are basically defined as later successional species. We all know what they are: red spruce, sugar maple, that take two rotations of their shorter lived comrades like balsam fir, paper birch, for example, and those analogs, to grow to financial maturity and biological maturity at older ages, right? So in order to keep them in the main canopy, you need to keep at least a two-aged, if not more aged, stratified mixed species stand structure, which I'll illustrate here in a minute. If you go in and just use low thinning without treating this as it's a plantation, you're going to wipe these things out. So that's not the way you proceed here. Lots of examples have been studied. Eastern hemlock and white pine with northern red oak is a good example, with the red oak being the one rotation, the hemlock and the two. Northern hardwoods are two rotation species when they're in competition with the faster growing black cherry, white ash, paper birch, and aspen, right? Red spruce, actually, especially the better the soils in competition with hardwoods and even balsam fir on better sites, is slower growing, but needs that two rotations of those intolerant hardwoods. And you don't have much cedar in Nova Scotia, but clearly cedar grows that way here almost everywhere. Here's one, just to picture a height growth pattern of these two rotation species. Here from Matt Kelty's work, we have red oak and black cherry on the upper lines and eastern hemlock on the lower straight line. Here's the hemlock. Now, so if you grow this hemlock out in mixture with these two trees to age 80, all right, and you clear cut the stand, the hemlock never reaches the main canopy. This is height, okay? So these oaks are up 17 meters tall. The hemlock's only 12. It has yet to bear any seed, so it's not going to regenerate and probably will be wiped out, and this will create a stand that's much simpler in composition. You can think of lots of examples where we've done this. If you retain that hemlock as a reserve tree, as a holdover tall regeneration, if you will, over here at age 0, harvest just the hardwoods, so they start from small advanced seedlings, grow rapidly, and eventually catch up with this hemlock. But the hemlock, for at least a period of several decades, is in the main canopy and getting larger than these other trees. And if you don't manage this hemlock this way, it's going to just go away. The same is true with red spruce, sugar maple, lots of other slower growing trees. This is their nature, right? To penalize them for not growing as fast as these others is just, not clear thinking about how to get the best out of our Acadian forest. So there it is. That's just that simple two rotation pattern. Now that you have this, you can harvest the hemlock, leave this other hemlock here, harvest the oak as well, or whenever, and this pattern just repeats indefinitely. And of course, you can make this more complicated if you want. So in summary here, irregular shelterwood, I would define, this is Kevin O'Hara's book, a similar definition, is anything that relies on advanced regeneration, recruited in the shade, that makes it shelterwood, does not use a diameter distribution as a target structure as you might in, say, a reverse J single tree selection kind of program that are used in other places. And but instead of that, you can use, and the area-based variants, area-based goals here, if it's a group shelterwood. And it also maintains the irregular part. It comes from the fact that it has this diverse canopy structure, including lots of merchantable trees that could be harvested, right? This is the collectively what we're thinking of as retention, right? So it is about both regeneration and retention. It's a silvicultural system. Here's Patricia's, if you can read this paper, you can study her 3 variants here. And these have come, I more or less agree with these. Mine are in blue here, hers are in yellow. 2 of the 3 variants are 3 or more cohort. They're group shelterwoods, which we've done these. You can expand these groups or not, but what we have done, she considers that 1 variant. Or if you don't have spatial recognition in it, and you just sort of the cohorts are just kind of all mixed up throughout the stand, then we call that continuous cover, right? But canopy, not like a plantation, but more of the stand is occupied by mature trees than regeneration, more or less everywhere. And then finally, we have the one I showed earlier, the simplest one, and this is just a simple 2 cohort thing, like we just saw with the hemlock, actually. And that would just be a uniform extended shelterwood with reserves, which she calls extended, and that's definitely it doesn't. There are times here when we don't have a lot of mature trees because the reserve trees are not as abundant as the regeneration typically in these systems. But they're nevertheless 2 cohort systems, and these fit. There are certainly natural dynamics like that as well that we can replicate with these. So the combination of all 3 gives us certainly a huge toolbox to do economically and ecologically based sensitive silviculture here. Now, when you think about retention, it's helpful, I've found in teaching this, and it's not just trees that you're leaving. I mean, we can call that the residual stand, but it's helpful to think about why you're doing this. And there are really 3 reasons. There's the new one, the biodiversity reason, where we're leaving trees for biological legacies, right? Franklin's idea that these enrich the newly developing cohort. There are things that are inherited from previous stands, maybe even remnant old growth trees. And their wildlife structures, all of the reasons we need big old trees that we're all familiar with now. We also retain, and this is temporary, we retain overwood trees. This is the term that we use for the overstory during the shelterwood regeneration phase to provide the seed and the shade we need for regeneration establishment. Once that does its job, we can remove that overwood and free the regeneration. Although some of the overwood can become legacy, these can overlap. And then finally, the most old-fashioned reason of all, like we'd have in commercial thinning, we can have the reason we leave a tree is it's growing stuff. We want to grow it bigger, right? Trees with growth potential. So thinning is one example, but those 2 rotation trees are another example, and lots of them. So this is if we're sorting through and leaving trees for these variety of purposes, you put that together and you have irregular shelterwood. Many of these overlap. Growing stock trees, of course, can later become legacies if you choose not to harvest them for their product value. Now, despite the fact it's unfamiliar to many Nova Scotians until recently, this is actually a really old system. It's really derived from the European system, the German system that they call Femmelschlag, that has really 2 variants. There's this, if you read Troop's old book here, 1928, or this article of Steve Spur in Forest Science in 56, you have the Swiss Femmelschlag. That's the continuous cover free-form variant, mostly French in origin. And then we have this Bavarian Femmelschlag, which is my expanding gap one, where the regeneration is organized into distinct groups that are cut and then expanded outward over a series of maybe 5 entries until all the big trees are gone. There may or may not be retention in these gaps. In a classic German system, there probably wouldn't be, but you would end up with a very irregular height growth stand. This is after the first entry in the systems. Now, my friend Klaus Putman, who's a silviculture professor at Oregon State, wrote this great book on the critique of silviculture, managing for complexity, and how we can use these more elaborate systems. He actually talks about the history of early North American silviculture, where in order to get any silviculture practice back, say, 1910, the early silviculturists, both in Canada and especially in the United States, they knew about these more elaborate German systems, but they intentionally decided not to import them and keep silviculture very simple and focus mostly on regeneration, natural regeneration, which was the challenge because there was nothing going on but exploitative logging. they figured these ones that are more complex in structure and elaborate would maybe come along later. Well, it took a while, but now they have, right? That we have sort of rediscovered these, I guess. I mean, I've been aware of them for decades now, as you'll see. There's lots of, if you come to northeastern United States or in Quebec, you would see lots of applications of this that have been going on for decades. I divide them actually into 4 categories. There's extended uniform shelterwood, where the reserve trees are large, distinctly kind of 2-storied structure. There's irregular, the same thing essentially, but where the old trees are the 2 rotation small trees, the holdover trees or the tall regeneration, so 2-age again. And then you get into the more complicated group shelterwood, expanding gaps, and continuous cover, which typically have more retention of mature trees over a longer period of time. I can show you all of these. Here we are in the Massachusetts wildlife agencies manage their land under this sort of 2-age system, where they leave large oaks and pines over a shelterwood matrix of regeneration, right? Here, in this case being wildlife, are mostly mass-bearing trees. The pines they do harvest timber and they make money. One analog for Nova Scotia might be the spruce pine forest group, where you'd have these black spruce white pine mixtures, sort of a daffy kind of climax forest in western Nova Scotia, mostly, I think, where you would have, you would regenerate the stand, but you would your retention in this case would be the large old, at least some of the large old white pines. Okay, but nothing in the middle really. The black spruce is going to die. There's nothing forming a mid-story here. These stands could have hemlock in them down in Massachusetts, but they haven't. I guess we see one right there. So there is a bit of a mid-story, but not a lot. The other way to go would be the classic sort of 2-age spruce fir, where you cut all the larger trees, mostly because they're vulnerable to wind damage at the end if you open the stand up too much. But these shorter ones, these holdover trees that are, 10, 12, 15 centimeters in diameter, 10 meters tall, 5 to 10 meters tall, are growing stock trees. Now, they don't look like they have high crown ratios, but you cannot use crown ratio as a measure of response on a short tree. Remember, that crown's going to build upward. That crown will not change at base, and within a couple of decades, that tree will have a large crown and will be healthy. If that tree were much taller, that's not true, of course. But here we have red spruce, white pine, cedar, etc., of these holdover trees from the old cohort in the mid-story and over advanced, 2-meter tall advanced growth of spruce and fir in those same species. So the same thing, so the 2-age. And then we have the irregular group shelterwood, which is my AFERP, the Acadian Forest Ecosystem Research Program Study. These are what I call large, sort of maybe not large for you, but 0.1 to 0.2 hectare groups with about 15% retention of permanent legacy trees, plus, in addition, any growing stock trees, the tall regeneration, and overwood if necessary in the groups. And the matrix is kept fairly fully stocked, lightly thin, right on the edge. We're looking into a gap here. If this were the whole stand, this would be continuous cover, probably. I talk about this at length. If you want to see, I don't have time here to go into this in detail in this webinar I gave on spruce fir back in 2016, which has almost 1,600 views now. But here's what it looks like looking down on it as a map. Each of these colors of blue is a cohort. The gaps, this is the expanding gap, but we don't expand them symmetrically, like the Germans might. We decided to do it sort of irregularly, asymmetrically, so we don't fragment the remaining matrix, the unregenerated portions. Each entry here is 20% of the stand. So that's so over 5 entries, you will have regenerated the whole thing on a 10-year cycle. So this has proven to be economic. One of the really nice things about this is that the skid trails are a very small fraction of the stand area, right? You can work outside of the regenerated area. You don't have to drive through it. A lot of other advantages. Here's some recent pictures of that where we've done expansions and retained a lot more sort of immature growing stock. Here's a gap, and we can look here. I show this to show us our different types of retention all in one place. This is interesting. Here's our legacy. We have an old white pine here. That's, in this case, probably going to go the distance. We're never going to cut that. And an old maple tree, right? A red maple, probably, in this case, which are uncommon. This is in this Acadian mixed wood that's around this area, this central, east central Maine area where I live and work on the Penobscot experimental forest. So there's your permanent legacy retention. Here in the gap, where we remove most of the merchantable wood, We've left a hemlock, and we've left a smaller, these two rotation, hemlock and red spruce, to grow into bigger red spruce. We will cut these someday, but they're 50 years away, right? It will be many entries into the future. Here we have we have some shorter regeneration, but that tree's very old. That's a 50 or more year old red spruce, only what, 8 meters, 6 or 8 meters tall, but ready to go. That's going to replace these big ones in the overstory, tall regeneration. And then we have some truly new advanced regeneration that we've recruited. So there you have clearly 3 cohorts, if not more, actually, maybe 4 if you count the legacies are older than the poles, older than this, and older than the new, right? But that's typical group irregular shelterwood right there. That personifies it. I'm a big fan of these group systems, and the reason is that unlike some other multi-age systems, we're managing regeneration deliberately here because we know where it is. It's in those gaps. So we control the gap size, we control the regeneration rate by the prescription, and we control the overwood in that gap. So we get what we want. It's just shelterwood, only it's only in patches of the stand, right, instead of the whole thing. If you figure, if the rate that you make these openings is within an ecological set of sideboards, like my 1% disturbance per year rule, or small gap turnover every 100 years in the Acadian region, then the ecological sustainability of this is more or less assured, right? Without worrying, at least in time, without worrying about other things. And you don't need to have any, when you're managing to a diameter structure as a multi-age system, you need to assume that all the big trees are old and all the small trees are young. And that's often not the case. Sometimes, as we've just shown here, some of those small trees are old. There's nothing wrong with that. They will respond, but we don't have to worry about that here. We're using an area-based, not a size-based system. All of these were problems. One of the reasons that single tree selection cutting became out of favor 50 or more years ago now was because a lot of these assumptions were violated, right? It became high grading, and people threw it out and began to practice simple even age silviculture. Pendulum is now swinging back to some degree, but hopefully not back to that. Now that's the ecological advantage, but there's a number of operational advantages. The layout, everything, all the layout, the designation of the reserve trees, the logging, the early tenning. You're going to plant this or do some PCT in there. Is all right in these patches. You know right where to go to do it. It's all focused. You don't need to work throughout the whole stand, right? So you're being very efficient about this. You don't need any pre-harvest DBH information like you would to make a marking guide or whatever. Nothing. And light harvest, because the harvests are concentrated. They're little mini clear cuts are feasible. The volumes are concentrated. They're not dispersed. The only extra cost here is moving the machine because you're not treating the matrix condition. But once you're in the blocks, the harvesting productivity is high. Here's our reserve trees. I mean, we have legacy trees that are just, wildlife trees, uncommon species, just big trees, right, that are hard to replace, and growing stock trees. We have both of those in this study. It's easy to designate these to get the right number. We're using English system here. We have a 15 BAF prism, so that's roughly 4 square meters of basal area. So you'd go out in these gaps with your 2-meter prism, and you'd have 2 trees in at any point in the gap. If you wanted to go higher, which you probably would, and if the gaps were bigger, you'd have more than that. So there's no prescriptive importance to put on that. It's just an illustration of how easy this is to do. Now, this is a huge good news story. We started doing this in 25 years ago now. 20 years into it, I had a grad student before I retired who measured 820 of these reserve trees. 92% of them are still standing after 20 years. That's extraordinary. And unlike any other retention study in the literature, where most of the retention trees were in clear cuts or in big blocks, right, standing out in the open. These trees being in these relatively small gaps, the aerodynamics are different, obviously survive, including, look at that, 150 red spruce, 88% of those are still standing. I marked a number of these personally, and I figured most of them would be down within 5 years, if not sooner. 88% of them are still out there. We can go look at them, and that's amazing. So there is hope for retention here if you keep the retention trees in these smaller gaps. There's some more New England examples. Here's our University of Maine Demerit School Forest right near the campus. It's mostly white pine hemlock. We just routinely, without really talking a lot about the details of it. Use this sort of continuous cover, 3 cohort system where we're trying to grow very large white pines. We have excellent market for these things up to, 30 inches, 50, more than that, 80 centimeters, I guess, or bigger. At maturity, 120 feet tall. We regenerate it with shelter wood in patches or uniformly, and then we always have mid-story trees, the hemlocks and spruces, and mostly red maple, hardwood in these mixtures, and intermediate pines, of course, and red oaks in this mixture. Very productive, managed with essentially fairly frequent light partial harvest, hand crews. The Baxter Park Scientific Forest Management does this. Sorry. This is sort of a very small gap approach where it's more almost a group selection approach where they go up to maybe 5 or more cohorts. Smaller gaps, releasing mostly red spruce. Here we are. They had me over in Vermont. They're looking for ways to restore red spruce where it's been wiped out or driven back into the corners. One of their young foresters happened onto this expanding gap thing, and we were over there looking at it. And they're basically doing this routinely now where they find these patches of spruce advanced regeneration. They'll lay out gaps, and then over time the idea is to expand those so that the spruce spreads out into the matrix. They don't want a pure spruce stand, they just want to bring back that mixed wood component. Here's Matt Kelty. He actually published on this. It's been around a long time on the Quabbin Reservoir in southern New England, where they use this to manage oak pine. Here's some of the pictures of it. It's a beautiful, fairly large gap with, lots of retention of both growing stock and probably permanent legacy trees. This is all done to manage water quality. Roughly 30-year cutting cycle where a third of the stand goes into these 1 acre or so gaps. So not, pretty interesting. And you think that's a crude system, but they love it because it keeps the stand no more than a third of the forest is vulnerable to catastrophic wind damage, which would threaten the water quality on the Quabbin Reservoir. Just simple, skillful, all tree marked with irregular shelterwood. So to wrap up here, some take-home stuff is that some principles that I just went through. If you just do these things, you're going to end up, I would argue, with some kind of irregular shelterwood, even if you don't call it that. And there are people over here that have been doing this a long time. If you conserve the small diameter growing stack, whenever you come to it, these 2 rotation trees, that's a big step. You don't want to do that to the extreme, though, of preventing regeneration. You can get a buildup, and we all know about this. Here it would be fir and beech would come in under the hardwoods, and you would get this undesirable low shade layer. You have to deal with that. But the idea, these are not trees we're going to be growing into the main canopy on long rotation, right? They're just filling up the understory. We need to get rid of those. But things like spruce and sugar maple and yellow birch and others, we want to promote those. So you got to distinguish between those, but that's easy to do if you have good markets. If the stand is patchy, use your group shelterwood model. And also, where wind firmness is problematic, as it is in a lot of Nova Scotia, I mean, I think these group approaches where you're keeping an intact matrix over a good portion of the stand area, regenerating in these patches, which appear to be quite wind firm according to our data, is, I think, going to work out better. I think we need to make more use of this in Nova Scotia. Don't go out there and do these string of pearls things where you just do these geometric patches with no retention every X, right, meters. Go out there and walk the stand, put the patches where the stand is telling you to put them. And if you don't have, like where there's patches of regen, if there's not anything there, then you need to do, establishment kinds of cuttings to get that regeneration established. Make sure when you're doing these groups that you leave retention. Some people just naively or falsely, I think, believe that once you do groups, you don't need to do any retention in them. That is just absolutely not true. Retention in groups is critical. You can get by, I think, with less retention in groups than you would out in a big block, just from wind firmness. But you need that light shade and you need that seed standing right there in those groups. And I think you also, of course, need the long-term permanent legacy retention that some of those trees will provide. So you have to have that. And then in any system, really, to manage for biodiversity, you can't harvest everything. You have to leave some large permanent trees as legacies to meet all the biodiversity objectives we have. And, of course, that could be a whole seminar in itself on the wide variety of objectives you would have for leaving those. But fortunately, we have these stands with 20 species. We have lots of options. Finally, my recommendations for the Nova Scotia matrix forest would be the following. Would be given the disturbance regime that's there in the Acadian forests and even in the highlands, I would more or less exclusively use some kind of multi-age silviculture, mostly irregular shelterwood. There may be, really interesting cases like intolerant hardwoods where you'd want to still stay with your single tree or small group selection, where you already had a 10 cohort forest or something, but that arguably is probably pretty rare. I think these irregular continuous cover shelterwoods are the gap-based ones where you have carry in 3 cohorts with long retention. Are going to be the way to manage most Acadian eco sites. I think where you have the simpler patterns with heavier disturbances at longer episodic intervals, like the Cape Breton Highlands, the fir forest out there, mostly stand replacing, but not entirely. There's always survival. So that's where you get into the simpler 2-age variants here. There's also the adaphic climaxes in the Acadian eco sites that are sort of site limited, that don't develop the species richness that you need to get the more cohorts, longer lived true Acadian forests. I think I would also make much greater use. As you can tell, I'm a big fan of gap-based silviculture. This is, I think, not just for the reasons that I cited, but also to manage the blowdown risk, which is significant. Everybody seems to be worrying about it in Nova Scotia, as they should. And finally, I think I would certainly hope that we have restoration pathways. It'd be one thing if Nova Scotia was all nice, 200-year-old, 20 species Acadian forest. I think very little of it is that, and probably a lot of that's in the protected areas, right? Commonly, I think we have, the SH stands. They're not necessarily spruce hemlock, yellow birch. They're red maple and balsam fir with some red spruce and some hemlock, maybe some of sugar maple in them. And we need restoration pathways to bring those forests back to the more Acadian stocking. I think you're going to find that irregular shelterwood, these variants will work well to do that too. Let's hope so. I think that's it. I think I just summarizes that we own land, as she said. We walk the talk. This is what we do on our own land, almost everywhere. It's going to take a bit of a cultural change, as I understand Nova Scotia. It's going to be a much more of a boots on the ground kind of a proposition. I think the prescription, the layout, the tree marking that's necessary, even just the reserves or maybe even the trees to cut, and the logging systems all need to be adapted to this new partial cutting kind of system. Maine has certainly done that, has done it for a long time, so we know that it's possible. I know there's a lot of skepticism, but I think people need to try. So I think that's my last slide. I put in some references. People want to go back and look at this and read some of these papers. There they are. Done.
All right. Thank you so much for that presentation. It was really informative. There was a lot, which is good. So to get started with the questions, a lot of what's left of old growth forest in Nova Scotia exists in patches. So 1 to 10 hectares that are smaller than or don't neatly fit into a polygon as mapped by the DNR and the Forest Resource Inventory. For example, an old growth stand may cross 2 or 3 polygons, so do not qualify as old growth under the current old forest policy. Would these be routinely retained under irregular shelterwood cuts in the revised Forest Management Guide procedures? Also a comment, I hope these would be retained in the high production forestry sites as well.
There's a lot in that question. I think I'm not an expert on the current evolving old growth policy. Just in general, obviously, if you had old growth trees or even stands, probably I would, if it was large enough, I'd probably reserve the whole stand just because they're so rare. If you have old growth components within stands that you want to manage in the matrix forest, then then the irregular shelterwood provides the ideal way to do that. And under some sort of high retention, continuous cover approach, probably is the way I would go with it. I'm not sure about the polygons. That's a mapping issue. You can always change that, presumably. I'm not, so that, yeah, I don't see a problem with that. The high production part of it, I would think that if you had a lot of old forest features, that the high production part of the landscape would be put elsewhere, and I'm pretty sure it is. That's the thinking, but I'm not involved with that planning either, at least directly.
Okay, great, thank you. So next question is in regards to pit and mound topography, which we have quite a lot of in Nova Scotia, just where there's no clearing for farming. How can we maintain some of the regeneration processes associated with blowdowns, pit and mound topography, for example, yellow birch growing on eastern hemlock blowdowns?
That is a problem in old field conditions because obviously those pits and mounds have been homogenized by agriculture. The one of the reasons for leaving, so in the long run, in a sustainability kind of thing, that one of the reasons for leaving large legacy trees is permanently is that they will not live forever, and probably they were mostly blow over in a windstorm, uprooting, and you will have your windthrow mounds scattered around naturally. That if you now foresters, of course, have to you don't want to wait for that, right? If you wanted, if you had a situation where you wanted to regenerate more yellow birch in one of these irregular shelter woods, some people believe. I mean, the most important thing in any regeneration effort is to have a big seed supply and then create the right environmental conditions near the forest floor. Yellow birch does seem to thrive on mineral soil. So any kind of you don't necessarily need a windthrow mound for this. You can just do some kind of modest site preparation. Sometimes just in the harvesting of the trees will create that. I have seen, now this is novel, and this bears on the issue of blowdown salvage. I'm actually a co-author of a paper where it was a large windstorm in Baxter Park, actually in the scientific area, that was salvaged, and probably 3/4 of the trees that were cut, that were laying horizontal, the root systems, of course, popped back into place. So you lost the natural windthrow mound that you would have had you not done the salvage, right? And there's no really sort of good way or safe way to stop that from happening when you're cutting. And the sooner you salvage, of course, the more it's going to happen because the soil hasn't really adapted to its new environment. So if we really want, once those trees go over, then probably if you really value the windthrow mounds, you should leave the trees lying there and not try to salvage them. Now that doesn't necessarily apply to a catastrophic loss where you, of course, if you wanted to salvage large areas that had all blown down from a hurricane, probably wouldn't need all of those windthrow mounds. Finally, I've seen another, this is really novel. You can actually, mechanical harvester can, especially a big feller buncher, can just push a tree over, right? Instead of cutting it off before it harvests it, pull it down, uproot it, or push it down, and then just cut off the bowl if you want the butt log off of it. Or just push over other trees that are less valuable, that don't have a lot of merchantable wood in them, and leave them there, right? And now you've got your windthrow mount. So that is an brute force way of doing it, and that probably wouldn't be all that expensive. I don't know what that would cost, and I haven't really. It'd be a novel approach if you really wanted to do it. I have suggested it at times for that reason, and again, mostly in old field sites where you've lost that heterogeneity in the forest floor.
Awesome, thank you. So next question is, one of the negative impacts of irregular shelterwood is the increasing harvesting costs compared to conventional clear-cutting harvest systems. How would you compare the changes or increase in these costs when implementing these systems in Maine?
I think that's only partially true. There are some aspects of irregular shelterwood that if you think about it, harvesting costs are primarily driven by pea size. So if you're leaving more of the small trees as growing stock, your harvesting costs will go down, not up. That can be somewhat offset if you're chasing around very low volumes in a continuous cover shelterwood. So if you're and that would happen when you're down around say 30% or lower removal. But if you're up on at a higher number, which most of these irregular shelterwood systems would use, cutting some of the larger trees, leaving a lot of those smaller ones, your harvesting costs are not going to be going up nearly as much as you might imagine compared to a pure clear cutting kind of background or frame of reference, I guess. What happens here, of course, is that the people that do this management, Maine Bureau of Parks and Lands, actually get more money for their stumpage, not less, when they bid out timber sales. Because guess what? Because they've been managing under irregular shelterwood for decades now, their wood is bigger in general, right? And their harvests have a much higher percentage of saw logs and higher value products than shorter rotation pulpwood harvesting with much lower piece sizes, much higher harvesting costs. So once the system is underway, the larger piece size will certainly overcome any of the other perceived negatives of lower volumes. They don't have to be that much lower, right? Because again, these trees are bigger and easier to cut. So it's not as clear as you might imagine. And so here, it's been built into the system. I think probably we, because it's new to partial harvesting of this sort is new. I think you will find if you do a lot of this gap work, I know it's hard to go by the matrix, right, and leave that lightly treated or even untreated, but the actual, we get regular stumpage prices for even these 20% removals because we have high volumes removed from those patches. And so yes, so the costs to me are more in the professional activity that goes to lay these things out, right? Find them, mark the trees for retention if you need to, or in a continuous cover, you need to mark the cut, perhaps, whatever. I suppose if you train operators, and that's done here too, if prescriptions can be done largely along species lines, then that makes it much simpler. That's often the case. These things can be done efficiently, right? I guess that's as much as I can say about that right now.
Great, thank you. So last question is, in regards to mechanized tree harvest and frequent forest entries, what would be the best practice to establish skid trails, which in clear cuts are not relevant? And what machinery or tree harvest techniques is best used at each step of entry?
Can you repeat the first part of that? What was the first part of that question?
Yeah.
It's about the lane.
So
Yeah.
in regards to mechanized tree harvest and frequent forest entries, what would be best practice to establish skid trails? Okay.
So from my personal experience and that of foresters that I worked with for a long time, the first thing that they do, even before marking any trees to cut or leave, would be to walk the block and lay out the trails. We've come to I got to convert this to metric. So I'm a big fan of cut the length operations because for a lot of reasons. I don't like grapple skidders. I would never have grapple skidders, full tree operations on my own land. I know that they have places, especially in the high production if you're clear cutting, but they just take up too much room. The landings are too big, right? I mean, there's just a lot of problems with them that that get in the way of good, sophisticated silviculture. So we're always going with cut the length. Long reach, the Ponzi Scorpion King is just a fabulous machine. The forwarders are a little big for my taste, but I mean, they're just still manageable, especially in larger wood. We use 80 feet center to center on those and often lay them out, 24 or 25 meters or so, center to center. You don't necessarily need an absolute rigid grid, but I think if you don't do that, the tendency will be to cheat on that and put them a slightly closer. And then you, instead of having 10, 12% of your stand and trails, you will have 20. That's a big difference. We keep track of this. The trees you lose for trails and access systems in these partial harvesting systems are important, and they're easy to ignore, right? Because the operator, oh, it was just in the trail, right? You laid the trail right through it, I had to cut it, right? Well, that's true, right? You can't. But if you're laying out the trail, you can anticipate that and or train the operator to weave around a little bit, not extensively, right? So I think trail layout is important. I think those are the numbers that we use. You should be able to get by with an operation where the trails are no more than, certainly 4 meters wide on that 24-meter spacing, and keep that footprint of the logging down. If you're using cut to length, you don't need very big landings and yards because you can pile your wood right along the road if you have to, or in small areas, and then truck frequently, and you're good to go. So that I used to think, before these modern cut to lengths came along, it was like, oh man, some of this mechanical systems are a disaster for these partial harvest treatments. But that with the modern cut to lengths, I no longer believe that. But forestry has to take charge and tell the operator what they want done through marking and trail layout.
Awesome, thank you. So with that, I think that's the last of our questions. Thank you so much, Bob, for the presentation. It's really informative.
You're welcome.
And that's about it. So for next week's webinar is going to be on backcountry camping. But the week after that, in the forestry professional series, it's going to be on migratory birds and forestry. So I think that would be a little more relevant if you're interested more on like the forestry side, especially with silent season just ending. Will be a good chance to kind of learn about that. But with that, that's about it. Yep. So if you would like to register for any of those, just email me as per usual. And thanks everyone for joining. Have a great day.
Okay.